next problem from Chapter 10, we have a probability problem. We have a bag containing 10 red chips, 15 blue chips, and 20 green chips. If you draw 5 chips at random, well, I ask, what are the odds that we have, what's the probability of getting 2 or more red chips? Now what I have written in blue up here is, you can call it the event space. It's the probability of every single event that could possibly happen. Either I'm going to draw 0 red, 1 red, 2 red, 3 red, 4 red, 5 red, and each one has a probability. There's no events that are unaccounted for, so if I add up all those probabilities, it better equal 1. Well, the probability of drawing red, more than 2 red, is defined by this group. This is probability that R is greater than or equal to 2. I'm a lazy mathematician, so I'd rather do less work when I could do more instead of doing more work. So I'm going to suggest that instead of finding probability of red greater than 2 by adding up all these probabilities, we instead calculate this. The probability that R is less than 2. Now both of these should add up to 1. So the desired number I want, probability that R is greater than or equal to 2, is equal to 1 minus probability that R is less than 2. That's the idea behind the complement, and I thought that I should write it out just this once so that it's clear. So the task before me is to calculate the probability that I get exactly 0 red and the probability that I get exactly 1 red. Now the way I do this is first I count up all the chips and I find that there are 45. Now every probability equation has a numerator, which is the number of successes, and a denominator, which is the number of total ways that you could do the experiment. Now here, success is defined by having 0 red. So how would I get 0 red? Well, I would have 10 choose 0. You don't have to write this because it's 1, but just so that it all adds up and so that you can see the patterns, I'm going to write 10 choose 0. Now we've taken nothing out of the bag, specifically avoiding the red chips. Well, we want to know how many non-red chips there are. Well, if there are 45 chips in the bag, that means there are 35 non-red chips left for me to draw from. And I'm going to choose 5 of them. My total event space is 45 chips, and I'm drawing 5 of them. If I run this calculation, I can ignore the 10 choose 0 in my calculator. I get 0.266. Just saying that there's about a 27% chance of getting no red. Then my probability of getting 1 red is equal to 10 choose 1, because there are 10 red chips and I have 10 choose 1 ways of getting them, and then 35 choose 4, which is the number of ways that I can choose non-red chips. All of this over 45 choose 5. And that's going to give me 0.429. I add these together and I'm going to get 0.694. And what is 0.694? Well, that's the probability of getting less than 2 red. Now, as we discussed, the probability that we want is getting greater than 2. So what I'm going to do is I'm going to do 1 minus this number. The probability of R being greater than or equal to 2 is therefore 0.306. Now we'll use the same approach to solve the next problem.